For the oxime synthesis, you will be given a ketone and you will have to create the oxime of that ketone. Again, just like our alcohol to ketone step, you can be given any ketone for the creation of oxime. There are few things that you need to remember while you're doing this experiment and while you're discussing its theory. The first thing that we have is this hydroxylamine. This is a solution, not a neat liquid, solution with molarity given to you. So make sure that you calculate its percent yield accordingly. Next, because we cannot have hydroxylamine on its own, we usually get the salt of it, the salt with hydrochloride. So the purpose of using sodium hydroxide, which is also your starting material in this experiment, is only to free up the hydroxylamine. Sodium hydroxide will react with HCl, neutralize it to form water and sodium chloride, and in the process, free up the hydroxylamine. If you remember oxidation, we generated in situ HOCl, which was the reactive species of your oxidation reaction when you used bleach and acetic acid. In a similar way, you are generating the hydroxylamine in situ by combining these two starting materials. So these are usually reacted in 1:1 ratio. The second thing that you should know is where is your nucleophilic part. This is the reactive species, and you have two reactive sites, a nitrogen with a lone pair and an oxygen with a lone pair. Both of these can react with your ketone. So it can either get attacked from the nitrogen side or it can be attacked from the oxygen side. However, which pathway will be faster? Whichever pathway will be faster, whichever will react faster, will win the race and will have major product from that nucleophile. So let's look at why it is the nitrogen and not the oxygen which will win this race. The reason is nitrogen is less electronegative than oxygen, and hence when this nucleophile attacks intermediate, a tetrahedral intermediate is generated. If you look at this intermediate, the incoming nitrogen has a positive charge on it. Because nitrogen is less electronegative, it will accommodate the positive charge better than the oxygen. Why? Because oxygen is very electronegative. This helps the nitrogen to form the covalent bond more easily. And hence, when both nitrogen and oxygen are available as nucleophiles, it is the nitrogen pathway which will win the race and make the oxime. Now, because we already have a ketone, we do not need for the electrophile to be stronger. Usually, when you have an alcohol Then the oxygen protonates it to make OH a good leaving group, making this carbon very, very electrophilic. However, in this ketone, we do not need to worry about such arrangement. And hence, this reaction can occur without the oxygen getting any extra help. So this carbon will be very electrophilic already. And moreover, nitrogen nucleophiles are very strong nucleophiles. So if you look at the order carbon, nitrogen, oxygen nucleophiles are strong, but nitrogen nucleophiles are very strong, and carbon nucleophiles are the strongest of this lot. So you need to know the mechanism of this part up to the formation of tetrahedral intermediate only. I don't expect you to know the rest of the rearrangements because it is a probable mechanism. Okay. Of course, there will be several proton transfers, but this is the major part of the mechanism. Overall, between the two steps that we have seen, your alcohol gets converted into a ketone, and this ketone gets converted into an oxime. When you will write your lab report, this is the kind of chemical reaction that you should write as the overall reaction, besides giving me the separate reaction conditions. In your lab report, you are also required to calculate overall percent yield. So you will calculate percent yield for the first step. You will calculate the percentage yield for the second step. And then you will calculate the overall percent yield. Just like I gave you an example in the oxidation experiment, we can ask any kind of an alcohol to be the starting material. We can ask different types of questions based on that particular step. So for example, this is your starting alcohol. What are these conditions for? These are for your oxidation conditions. At the same carbon, you get the ketone. What are these conditions for? The hydroxylamine hydrochloride salt, sodium hydroxide. These are the conditions for oxime formation. You will just replace the oxygen and place the nitrogen on that carbon, OH and H. Whatever happened to one of these hydrogens? This hydrogen is making this nitrogen as a positively charged species. We want neutral species. And in your enamine and amine synthesis, you will see that when you have two hydrogens to give away, both of these hydrogens help to make your double bond. That is beyond our lab course. This will be part of your lecture course. You just need to remember to remove two hydrogens from this starting material. So let me ask you of this. I know this is my ketone. What should be my reagent here to get me a product like this? So what do I have here? I have a nitrogen. I have the CH2, CH3 group. I need what else? Instead of OH, I have this ethyl group. So what do I need to put here? NH2. So this is one of my reagents. The second reagent will be sodium hydroxide. These are the two reagents that I will need to create this particular product. Oxenes also have geometrical isomerism. If the bulky groups are on the opposite side, we usually call them what? Trans. Or E, if the priority groups are not exactly the same. Similarly, if the priority groups of each carbon are on the same side, then we call them cis or Z. So we follow the similar kind of nomenclature for our oxenes also. But you don't have to worry about that. You just have to worry about creating the right structure, figuring out the right kind of reagent, thinking beyond the part, how will I able to distinguish between these structures based on IR, based on NMR, based on DLC plates if possible. Think about polarities. Think about the hydrogen bonding, missing or present. Think about all the kind of different permutation combinations.